Hello. Welcome to EE Craft. In our recent videos, we've been working on building an internet-connected clock using ESP32 hardware with a built-in TFT display. The clock connects to a Wi-Fi router to get date and time information from an NTP pool server and then displays the time and date on the TFT display. In this video, I will show you how to add a climatic sensor, BME to AT to measure temperature and humidity. Let's display that information on the clock's display as well. The intention is to add a mini weather station avatar to the internet clock, to make it more informative and smarter. To include the sensor BME to AT in the ESP32-based T-Display board, we used a sensor breakout board installed on a connector soldered to the same general-purpose board as the ESP32. As illustrated here, it is quite easy to get the BME to AT sensor connected to the ESP32 board using just two signals, as the sensor supports I2C as the interface. In addition to the I2C data and clock pins, it is necessary to connect the VCC to the 3.3V pin of the ESP32 board and GND to the ground pin of the same. In this project, we utilized the same general-purpose board, featured in the previous video, demonstrating how to add chiming capability to the clock. We connected a header to the I2C interface of the ESP32 board, using wires soldered between the ESP32 header and the sensor header. The sensor breakout board is then just plugged into the same header. Let's enhance the Arduino sketch to read temperature and humidity values from the sensor and display them. We need to include the necessary libraries to talk to the sensor successfully. Please note that the library included in this code is compatible with the specific breakout board used in this video. Your sensor board may require a different library if it is not the same as mine. Next, we need to define any sensor-related constants. One such constant is the I2C address of the sensor. Please note that the address may differ if the breakout board is from a different manufacturer. Thus, you should update the value to match the I2C address of your specific sensor. In the sketch, we need to declare the name of the constructor for the sensor object. We are using the Adafruit library for the BME to AT sensor, and hence the statement here reflects the same. The name of the object chosen is BME. Let's now move forward to the setup function. You may already know that any code we want the microcontroller to execute only once should be included in the setup function. We need to insert the code for initializing the sensor here. I need to take a moment to make some adjustments to the code. Since the controller needs to print a message on the serial port if the connection to the BME sensor is not established successfully, I will move the statement that initializes the serial port before the sensor initialization statement. It would be best to write the serial port initialization statement at the very beginning of the setup function. In an Arduino sketch, we write the repetitive tasks in the loop function. Therefore, we will write the statements to retrieve data from the sensor over the I2C interface here inside the loop function. Similar to the function that prints local time, we are using another function to display the temperature and humidity data obtained from the sensor. Next, we will define a function to retrieve temperature and humidity readings from the sensor and update these values on the TFT display. Before doing that, let's define the variables that will hold the previous and current values of the temperature and humidity readings. If you have watched a couple of videos on the internet clock posted on this channel, you should understand why we are doing this. We need to know if the current readings have changed from the previous values, so that we can refresh the screen before updating it with the new readings. We also need to initialize these variables. The links to the previously posted videos on this topic are provided in the description box for your reference. Please note that the clock is primarily designed for indoor use, so I do not anticipate the temperature dropping below 0 degrees Celsius. Therefore, I am using an unsigned variable for the temperature data. However, it could also be represented using a signed variable, which would require adjustments in my code to display negative values correctly. Next, let's complete the function to print temperature and humidity data. I will take a pause here as you can follow the comments. The function is now complete. Please note that the cursor coordinates are calculated based on the screen size, the position of the text, and the text size. These coordinates may vary if you have a different display or if you want to display a larger or smaller text size. Since I rearranged the text positions to accommodate temperature and humidity data, I need to update some of the coordinates carried forward from the previous version of the sketch. Allow me to make those corrections. That is all. The next step would be to upload the sketch into the ESP32 board connected on a COM port. In this comparison, I have emphasized the differences between the previous version of our internet clock and the latest model, which now features a sensor. You will see that additional information is displayed on the same compact screen. We can improve this further. Let's take some time to think about how to make it better. If you enjoyed this content, please subscribe to the channel. Keep visiting. Thank you for watching.